Hello students, this is going to serve as a review video for you as you are working through the different types of plate boundaries in preparation for the quiz that's coming up. So I'm going to walk through the basic boundaries with some drawings as review. The first one we're going to look at, these are all going to be from the convergent boundaries. Convergent boundaries. Remember that when you're dealing with your word hint there is that they are coming together. Convergent boundaries. And so what we're going to look at first is oceanic and continental crust coming together. So this is an oceanic continental convergent boundary. So to draw this, you're going to give yourself some oceanic crust, and as we know, it will subduct. And we'll give ourselves a nice big continental crust there. The convergent motion tells us that these are both going these directions towards each other. And just so that we're clear, we've got some ocean there. And then we have to have a couple important formations here. One of them is a volcano. We know this volcano is occurring because we have subduction. Subduction. This is an important label for this type of boundary. Remember, sub as a prefix, you're thinking under, right? Subway, submarine. So that that crust is going underneath that large piece of continental crust. You've got your volcano here. You've got your subduction here. The reason for that is as this gets deeper and deeper, that crust is going to melt. And due to the density dropping, the material will rise, and that is what's going to slowly form that volcano. But remember, subduction, yes, always has a volcano, but it also will always have a trench. This is that pinch zone where the oceanic crust is pulling on the continental crust a little bit as it is subducting, and you'll have that trench. In the drawing, it looks like it's small, no big deal, but in reality, we know that those can be 2-3 miles deep. So that is your oceanic continental convergent boundary. Now let's change up a little bit, and let's just do continental, try to fit it in there. Continental convergent. Same thing, you've got two crusts that are coming near each other, except for this time, when they collide, they're going to be smashing into each other, and they're going to be folding as to create a large range of mountains. These are plain Jane, boring mountains. There's no subduction occurring. This massive crust, you can even draw it bigger if you want, is not going under the other one. They are just crashing together, and you've got sort of an uplifting. You can do that if you want to signify that that rock is folding onto itself. If the oceanic continental that we just reviewed happens, near us, to explain that the volcanoes that grow in Oregon and Washington and Northern California, this one, these are just mountains that are just non-volcanic, and so maybe you're thinking more like the Himalayas, Mount Everest, that mountain range where it's just rocky mountains, non-volcanic. However, you can have oceanic crust and oceanic crusts that are converging. So let's throw a last label here, oceanic, and it's going to look really similar to oceanic continental. You're going to have two crusts that are coming together. You're still going to have one subducting, okay, because remember, whichever one is more dense is going to subduct. So you've got two oceanic crusts meeting, one of them is going to subduct. You're still going to get the melting, but this time you've got your water all the way across. We're now dealing with the ocean floor. And so over time, this magma is going to break the surface, slowly grow a volcano until it does break the surface of the water. And what we have here is a volcanic island. This is the primary way that we get islands. It's not the only way, okay? This is not how Hawaii was made, but this is how many other islands around the world are created. You could say Japanese islands, you could say the Aleutian Islands in Alaska. You still have subduction, you still have your trench right here. So it looks, anytime we see subduction, we're gonna have subduction, a trench, and a volcano always together. It just happens to be growing from the ocean floor instead of directly on the surface of land. Now, moving forward, let's go to another type of boundary here. Let's go to divergent. Divergent boundary. Your word key is that div at the beginning. So this time think divide. So these are tectonic plates that are moving away from each other. And let's say let's start with continental. Let's just say we've got two plates that are both on land. They're moving away from each other. This is kind of how I like to draw this because this is how I imagine it. I like to kind of imagine this as you're staring down a ravine. Okay, you can put a little guy here if you want to. He's walking down a path where he's got two sets of tectonic plates on either side of him that are moving apart. This is like in Iceland, right? Iceland, they have a lot of these locations where you can just walk around and maybe this is North American plate and this is the Eurasian plate. And they're literally that close, you can nearly touch them. Oh, excuse me, this is continental. So this is on land. Now, on land, we would call this area, we wouldn't call it a canyon. A canyon is built a very different way. We would call this a rift, or you could also call it a rift valley to help you remember. In these places, maybe it just splits and some of the rock and sand falls in from above. But in other places, it may fill with water over time. Maybe a river diverts to it, and it could create a very large lake, or even potentially start building a small ocean, a small sea. We see this in Africa. There's a lot of places that are like that. Now, if we throw it into the ocean and we say, okay, it's still divergent, except for now we're dealing with an oceanic location, it's going to be very, very similar. You still have your big hunks of land. I like to give it a little bit of a wiggle there at the top. And then create some sort of chasm right here. And then what you're going to do, give us some directions and give us some magma that's coming up. And this magma is going to be filling that slot. Remember that this magma comes up, and because it's under the water, it's going to cool right here. So it doesn't really get a chance to form. You know, some students would say, well, a volcano is going to form there. Yes, but no, it doesn't really have the chance, because just as this rock begins to cool, the plates on either side of it spread it apart, and it leaves these trails across the ocean where it's just split open. And then more magma comes up, cools, and then it splits as well. This is really similar to a rift, except for we call this one a ridge. A ridge. And these can be massive ridges all across the bottom of the ocean. Your most popular one, the Mid-Atlantic Ocean Ridge, which goes from above Iceland, which is basically in the Arctic Circle, down to near Antarctica. So that is your divergent, but in the ocean. And the other one was your divergent, but that was on land. Keep in mind, this is where we have that concept of seafloor spreading. Okay? The reason that's important is because this tells us where the ocean floor is growing. Of course, this is going to be growing here, but eventually it's going to run into continental crust and it'll subduct on the other side. Lastly, maybe the easiest one is going to be transform. This is your transform boundary. Transform's unique, means one's going that way and one's going that way. This one isn't really all that difficult to draw. I like to just keep it simple and imagine that I'm like looking down on a map and I'm identifying two sets of tectonic plates. and let's say one is going this way, one is going this way, and they're scraping along the side of each other. Now, be careful as you describe these. Don't just use the word opposite. Don't say they're going in opposite directions. That's technically true, but however, I would say that that is opposite and that is opposite as well. So technically all these boundaries are going opposite directions. What I would say is maybe that they are scraping along the sides of each other, right? They're sharing a boundary and they're moving, they're sliding alongside each other. Nothing gets formed here. There are no formations. So there's no mountains, there's no rifts, there's no ridges, nothing is formed here. The only thing that is important is kind of knowing where these are. The most basic place that most students are aware of is the San Andreas Fault. San Andreas Fault. A fault is what we would actually call this location right here. The actual spot where the transform boundary is making contact, we would call that a fault or a fault zone. These places get a lot of earthquakes. That's pretty much it. All the boundaries get earthquakes, but that's pretty much the only thing that happens at these ones. They're shallow earthquakes. We get them all the time in California because of the San Andreas Fault. Okay, that was a quick run through, some basic drawings as well as some basic vocabulary. Please reach out to us if you need a hand in preparation for your quiz.